Hi, welcome back. Now we're going to do number 36 to 40. Now, the table presents some point in the graph of linear equation or linear function g. So this is g, table of g. The graph of g was translated 10 unit down to create the graph of h. So kind of we have two graphs, g and h. Which statement comparing the graph of g and h is true? So we're looking for a true statement. So you know what? This is what I tell my kids always when you're dealing with the graph or you're dealing with transformation. So you're moving over the y or over the x. Guess what? Imagine. So this is g for negative 413, negative 210.5, 2 it's 5.5. So kind of this is kind of your g. It's going down. You can see it. This is the line. What happened to this line? Moved 10 unit down. Moved down, you see, from this position to this position. To create a new graph, they want to call it H. Now, we know these two lines, if you move it, if you shift it down or up, you're going to have the same slope. So let's see which statement we can cross. The x-intercept of the graph G, it's 10 unit to the right of the x-intercept of the graph of H. So you're moving down. You're not moving to the right or to the left. So this statement is false. The graph of G, it's steeper. Steeper has to do with the slope. So let's see. Any statement has the word steeper means that's incorrect because both lines has the same slope, so no one is steeper than the other. Steeper if the first slope it's more than the second slope, so the first line it's steeper than the second line. So you see we can cross G and J in this case because they're talking about less steep and steeper. So let's see H, the y-intercept of the graph of G, 10 unit above. Yes, if this is a G and this is H, yeah, G it's 10 unit above because you shifted 10 unit down. Yes, so this statement is true. Now, they ask you to solve an equation. This is what I tell my kids, use a calculator, it's fine. But before you do that, make sure your equation equal to 0. So in this case, we're going to set this equation to be equal to 0. So subtract 18 both sides. So you're going to have 3x squared plus 15x minus 18 equal to 0. Now you can solve this quadratic equation by using Pauli. Okay, let me use a calculator. So Pauli roots, then open your parentheses and plug your quadratic equation. 3x squared plus 15x minus 18, then you do comma x, enter. So this is both solution. The first solution is -6, the second solution it's 1, so we have two solutions. So which one will match? There, bingo, B. Now, let's see this question. A factory worker packed 12 boxes at a constant rate, took a 30-minute break, and then continued packing boxes at twice the rate before the break. The worker then spent 1 hour cleaning the area. Which graph model this situation? So, you know what? This is easy. It's not hard. So imagine you have a worker and we're gonna see the paste. So this is the time and this is the boxes. So they told you when he started, he was working at 12 boxes per hour at constant rate. So he started at constant rate, constant rate, constant rate. Then what happened? He took 30-minute break. 30-minute break means he did not he did not do any boxes. That's why it's flat, horizontal. Horizontal means the slope is zero. There is no boxes done, no boxes. Here you go up and you took 30-minute break. And then after the break, what he did, he doubled. What means double? Means the rate. So the rate of the new line should be double, means the new line should be steeper. Steeper, something steeper. Because you double means you multiply by 2, steeper. If this is 12, this should be 24. Then after he took break for an hour, if here he took 30-minute break, the hour should be twice as 30 minutes. So twice as 30 minutes there. So we're looking for something look like this. So in this case, guess what? This is, and this time they're not compatible because the 1 hour, the last one should be double. So no, it's not H. How about this one? The same thing. These two sections. This should be 30 minutes. This should be an hour. Yeah, this could be. This is 30 minutes. This is an hour. But what happened? I see this line more steeper than this line, which is incorrect because he has 12 and 24. So this line should be steeper, which look at A, at F. Your line go at constant rate, then you take a break, then the new rate is more steeper than the first one. More. Then another hour, yes, twice. So the answer would be F. The table represents some point in the graph of linear function h. So this is h, we know it's linear. Which situation can model this function? So we know this is 2, 490, 5, 295, 6, 230, 8, 100. So we see something going down. You see how the number of the y, when x go up, the y goes down. So this is your line, h of x. This is how we see it. So they want to use whatever they use. This is, you're going to match a real life situation. So in this case, let's see which one. The cost in dollar of buying X item that costs $2.45 each. X item, so if you buy 2, if you buy 5, it should cost you more, not less. So it's not going to be A. The number of mile an airplane had to travel after flying 550 per hour for X hour. Guess what? The number of mile has to increase, not decrease. So it cannot be. The remaining number of mile on 60-20 mile trip after traveling 65 per hour for X hour. We're going to leave this for a little bit. We will come back to this. Let's see, the amount owed $555 loan after paying $65 per month. Let's see, $65 per month. Do we have that rate? Let's see. So 100, that's negative 130. That's 2. That's negative 65. The amount O at 550. So if you go backward, 490 minus 65 and minus 65, so 490. Because we need to see the initial 490. No, it's not going to be 490 because the initial value is going to be less than 555, less. So you're telling me this is my starting point and then 65. Yeah, it's 65, the rate. The rate is good, but it's not 555. We cannot start with 555. But let's see, if you do 490 plus 130, you will see it's not going to be 620. So we should start at 620 right here at 0. That's your y-intercept. That's your starting rate at 0 when x equals 0. So it's not 520. You see here, 620. There. We start at 620 and travel 65 per hour. Okay. Now, we have inequality, and they ask for the value of x when y equal 46. So y less or equal than negative 6 times x minus 18 minus 2. They give you the value of y, so instead of y, you're gonna put 46. Then you're gonna solve for x. What means solving for x? Means we have to keep the x by itself. In this situation, always when you see parentheses, you have to distribute. Always applying the distributive property. Negative 6 times x, negative 6x, negative times negative plus. You're gonna have 48, and then 108, then minus 2. If you want to check right here, 6 times 18, always there, 108 minus 2, then 46. Now you want to solve for x, so you're gonna keep the x by itself. So this is 106. You subtract 106 both sides. So finally 46 minus 106. So 46 minus 106 equal to negative 60. So negative 6x. So now you're going to divide by negative number, and this is the trick. When you divide by negative number, your sign flip. That's the key. So in this case, x has to be less than 10. This way or this way, it's the same. You see how the x, it's less. Like if you use the crocodile, x in the belly. So the answer would be F. I hope you enjoyed this video.